programming language. It was made by two guys, Ari Bornswig and Juan Journeman. I have very hard names to pronounce. It's a object-oriented programming language, so that'll be fairly familiar for everyone, which if you're not familiar with what that means that it basically has classes and instances of those classes and everything orients around objects. It was influenced primarily by Rust, Ruby, C, Go, languages like that, so kind of this need to now kind of get more towards the bare metal while still providing developers with a friendly interface. So if you've ever looked at the difference between maybe writing some C code and some Ruby code, you'll kind of understand what I'm talking about, so that friendlier developer interface. It's a completely bootstrap language, so when they talk about bootstrapping, that basically means that the Crystal compiler is written in Crystal. So as it started out, the first compilers were basically written in Ruby, and then once they wrote enough Ruby code to compile enough Crystal code, they could rewrite the compiler in Crystal. So basically it's an evolution. So when they talk about bootstrapping languages, that means that the compiler is written in the same language that the language is. So that just kind of happens, like I said, with the evolution, starting with a very basic thing that you can compile in Ruby, and then you write enough of the Ruby that you can compile enough of the Crystal that Crystal can start compiling older Crystal code. So you make your improvements by writing new Crystal code and then compiling that with older Crystal code. And then in a lot of changes, or in a lot of places, it's so similar to Ruby that you can run the same example code that is a Ruby file in Crystal in Ruby. So in a lot of cases, it's interchangeable, but it's not a requirement of the language. So in a lot of cases, as you start adding some of the new syntax that Crystal brings in and the types, you'll lose backwards compatibility to Ruby. So anyone who is out there right now, I invite you to go to this website. This is basically an online sandbox. So you'll go there, it'll give you like a little text editor window, and you can start punching in even some of the examples that I show up here. And you don't even have to download the compiler, you don't have to install anything, it'll compile on the server and just give you the results. So if anybody can grab that. And then later, I just put things like this in the slides so that if you download the slides and want to kind of know how to get started, you can go to this URL. If you're not using Mac, if you are using Mac and have the homebrew system, it's basically you just want to do an update to pull the latest stuff, and you can brew install the Crystal language, and then that should give you the compiler and everything you need to get started. So just wanted to share some of the major overarching goals that led to the creation of the language. Like I said earlier, they want to have a syntax that's similar to Ruby, but compatibility with it isn't a goal. So like I said, just because of the strong type, the syntax will change. But in a lot of cases, it's very easy to port Ruby code to Crystal. It's a statically type-check language without having to specify. So I refer to this as being implicitly, or an implicit type language. So you can't explicitly say what the types are, but it can infer in a lot of situations based on the variables that you're passing to it, what those types need to be. So in a lot of cases, you can omit the types, and the compiler is smart enough to figure out what types you're talking about. So that'll give you a little bit of the familiarity that you're probably used to in Ruby, which is like more like duck typing, where it just kind of figures out things on its own. This is kind of true of everything, but you can call C code by writing bindings to it. So if you've ever used anything like FFI or native extensions in your Ruby code, it has the same abilities. And in a lot of cases, you can actually write native extensions for Ruby, basically extern C modules, so you'll get like a shared object out of the compiler instead of an application, and then you can write Ruby bindings back to it. So if you really like this and you have a need to basically create like a native extension for something in your code, it's possible to write that in Crystal, compile it down to LLVM, and then basically write a binding for it in Ruby to utilize that. Yeah, and then this just goes to say, like, this is something you'll see a lot in Go and Rust. The compile time evaluation and generation of code to avoid boilerplate code. So in a lot of cases, that compile time evaluation is kind of, I'm trying to think how to like describe this. It just kind of helps you pinpoint where some of the problems are, and then it can also kind of generate in between stuff, so you don't have to write a bunch of stuff. It kind of does it as part of the language, and then compile to efficient native code. So if you're familiar with Ruby and how it works at all, it's a interpreted language. So basically, the Ruby interpreter runs the Ruby files like in the process, and then kind of does that on-the-spot translation to the code that's going to run on the system, where in a language like Crystal, you compile it all ahead of time, and then that's what you run as native code. So practical uses. This is like a very contrived example just to kind of give a demonstration of what the compiled versus the interpreted Ruby code kind of looks like. But we can take this example over here, which is a very basic Fibonacci sequence algorithm, and when we basically compile and run it as Crystal, which is done right here, when we run it, it takes about 1.17 seconds. And then we run that exact same file. You'll see right here, because like I talked about, the language is often interchangeable. We can run that CR file just with the Ruby, and it'll run the same code, has the same output, but with a time of almost 46 seconds. So that's kind of one of those cases where you can build like a very basic benchmark that will run in both, and see what's going on. Let's see here. Okay, so I said it's kind of like a type optional language because it can infer things based on what you pass to it and how the code's laid out. So it'll run both of these examples, but this kind of starts to show you where the languages can diverge. So in Ruby, you typically see something like a def add x comma y, x plus y, and then that would like return the result. So if you did 5 and 3, it'd be 8, I think. And then down here you can see, now we start getting into some of the types. So it's the exact same code as up there, but now we're saying x is going to be a number and y is going to be a number. So those are some of the classes, and then you do that. So that just kind of starts to show how that they syntactically can be different when you start to type things. Okay, so this is something I've always wanted to be able to do in Ruby, and something that gets me kind of excited about Crystal. So you can have the same method, and then basically the language will determine how to run each one of the code samples based on the arguments that you pass into it. It's what's known in languages as overloads. So basically, you have two different code paths here with the same name, and they're called exactly the same way. But you can say x number, y number, x plus y, and then down here you can have x bool, y bool, and then you can define like the logic, so x and y. So basically you can call this with two different things, and in this case it'll run here, and in this case it'll run here, because it identifies that you passed a boolean or a number, and then it picks the proper overload for the code. So you'll see here that the output of this code when we run it would be 8 when we say 5.3, and false because we've said x and y, true, false. That'll basically return a false value. Oh, feel free to jump in with questions at any time too. That was one thing I did mention. I'm pretty laid back, so if anybody has anything. Okay, so this is kind of what starts to happen though, if you mess it up. So like basically when you define these overloads, you have to pass it in one of these formats, because if the signature for the method that you call doesn't exist or doesn't match, you get your first compiler error. So this is kind of showing what the compiler errors look like and how that works. So basically we've defined that xy with the booleans and the numbers. We've tried the 5.3, the true, false. So then here we basically pass a number and a boolean, and since we don't have an overload that's like that, you'll see these are the valid overloads. There were no matches for the overload that you passed in, so it's going to throw a compiler error. So again, one of the nice things about the compiled languages in this case is that the compiler tells you ahead of time. Oh, go ahead.
Can you specify return types?
I believe so. I haven't shown that in any of the examples, but yeah, so what he's talking about basically is there's often an annotation in these languages where you can say like what it returns, and basically the compiler would throw an error if you don't return that type. That's not something that I dug into for this, but I believe that that is possible. Yeah, so basically what I was saying was that when you do this type of code, and it's compiled ahead of time, one of the things you run into with Ruby is like it'll crash, it'll throw an error and an exception because your code's there and it doesn't realize it until it tries to run it. With this, you'll know before you deploy it even. So while I'm not saying you don't need like specs or tests or anything like that, this just adds another layer of redundancy that you've not made like kind of a foolish mistake and passed like a string where you should have passed a boolean or a string where a number was supposed to go. So it helps define an API within the language. And when you're working across like a large team, often this type of type checking can make you a bit more productive because everyone kind of understands what's expected everywhere because you like explicitly called them out. Okay, so this is another cool example. So you can explicitly implement undefined behavior. So I guess like the thing here would be that everyone kind of knows what adding is for like two numbers, and it's like kind of you can figure out what happens when you add a Boolean to another Boolean. That's easy to define, but like what happens when you define or when you try to add a number to a Boolean? One of the really nice things that's extensible about this language is basically anything like that you can define and implement your own logic for. So in this case, we basically say if the Boolean's true, return the number. If it's false, return 0. So I thought that was kind of a neat feature of the language. So this is cool too. So when you are implementing a class, let's say, it's very easy to implement operators. So this is possible to do in Ruby and other languages, but one of the really neat things here is that you can define like how two things get compared. And you can do it in a real interesting way, especially with the overloads. I have a Ruby example over this to kind of contrast this, and we'll talk about some of the differences once we get there. Basically what we've said is, we're setting a getter, so in Ruby land, a getter would be much like an attribute accessor. We just call it a getter here. So you can think of that as an attribute accessor in a class. On an instance, we set up an initialize function, so this is kind of the quote-unquote constructor that you'd have in most languages. And then we take an argument that's at name string. So this kind of gets into a little bit of like, I'm trying to think what, like decomposition almost. Because you basically said that this variable should be named at name with a string, you don't have to assign it inside. It automatically basically gets assigned to at name, which is an instance variable. So you can just basically define that, and then your instance variable automatically gets set. You don't have to explicitly define it as like self.name equals name. It just kind of gets decomposed right there. Then for the equal operator, so you can see if like one object is equal to another, we have the special type self. So basically when you're declaring a class, you can take a typed argument of self, and that will always refer to the class inside of it. So basically what we've said is we're taking demo as the type here, because that's self, and then we're comparing it to others. So basically if you pass in another demo object, it'll read that demo object.name and see if it matches basically the local name that got set here through the setter, or through the getter. And then down here you say equals other that's untyped. So this is kind of like a fall through. So any other type of object that gets passed into this class will hit this kind of code path in a way and just return false. So down here you can kind of see we declare a new demo object with a name of Justin, we declare a new demo object with a name of Greg, and a third demo object with a name of Justin. So we say puts A equals B, that's going to come back false, puts A equals C, that's going to come back true. Now, when we hit this one, I don't know, that's the next example. So yes, basically we're comparing the name here because we're passing in or comparing the type of demo. So this is where it gets like really interesting. So when we compare a demo to not demo, it doesn't even do this comparison up here because it's got a type of not demo as this object. So it just hits this code path and immediately returns false. So then you skip that whole if statement that you typically have in Ruby. So I can kind of give the Ruby example next. This is what that same kind of class would look like typically in Ruby. You have your attribute reader, like I talked about before. This is where you have to explicitly take in the type name and assign it to the instance variable name. And then you take in that def other, and then you have to check, is other a demo to satisfy that condition, and is other name equal to self name. So kind of the difference here is we're doing that logic all in one method, where when you have that strongly typed overload, you can break all of those different code paths kind of into different functions. And if you think about when you scale like the code base to like 50,000, 100,000 lines, and you're building all this logic into functions, the overloads can really help break that up into more conceptual units, so you don't have like a ton of spaghetti logic like within your method declaration. So I think that's one of the really strong points about the language is the ability to do those overloads and deal with different objects independently rather than trying to mush them all into one big function declaration. So same thing here. So we have the three names, we just do a bit of logic, and that kind of proves that like it runs the same way on the output, but like, you know, it looks very similarly. Okay. So the next thing I'm sure everyone's going to ask me about is, well, what do you do with hashes? So basically you can declare like a hash the same way, and you can kind of create these one-off hashes and type them here. So here you're basically defining the key value types for the type of hashes you're going to put in here. So basically you can say E equals a hash of string Boolean. So string being the key type and Boolean being the value type. So this is completely legal. You say hello equals true, hello equals false. You can see here that it outputs. Now this is kind of where the typing comes in again. So you can see here kind of what a failing example looks like. We have E hash of string to Boolean. We set the key as hello true, set the key of world to false. Then we try to set the key of 11 to fail, which is a string. And we get this error in the compiler that basically says no overload matches hash string bool with types of int32 and string. So basically, it's saying that you can't have in this specific hash a integer key and a string value. So that again allows you to type things like those hashes. So you may ask, well, in my code I need to have integers and strings as my keys, and I need to have strings and booleans as my types. You know, like how do we do that? So the language allows for mixed type hashes, and this is pretty much true of any function declaration. If you want to take in multiple types and deal with it yourself, you can. But basically, you just use the pipe to delimit the different types of types when you use them. So you can say a hash of strings or integers, a hash of booleans or strings, and then all that code works. Everything's fine. And then basically the same thing's true of arrays. So they want you to type the array, so you have the array of string or integer, and then you can put 11, you can put A, you can put 22, anything like that. But one of the really cool things about this is it allows you to kind of enforce certain types of data, and that can be useful, like say if you're like reading like CSVs or anything like that, it kind of helps you make sure that your data is good that you're putting in there. Where with Ruby, you might pull, you know, who knows what out of something and put it in there and accidentally like corrupt something. So it really kind of helps enforce that strict typing. So that's kind of the general language overview. Does anyone have questions about like, I guess like the language before we kind of talk about like some of like the different like dependency managers and things like that? Yeah, sure.
Back when I saw Crystal kind of becoming more popular, they were trying to get it to run on Windows. Does it run on Windows, or is it only Linux and Unix-based?
So when I was setting this up, the installation guide only had Mac and Linux variants. So I don't think that it's running on Windows right now, but you never know. I guess one of the options is, like, I don't know if it's just like more of a curiosity, but Windows Docker's come a long way, you know, so you could like build your app and run it through Docker potentially, like in like a really like lightweight container.
Yeah, I wonder if the Docker on Windows would probably work too.
Yeah, so that's really cool too. So what he's talking about is Windows 10 just recently shipped with kind of this like, boy, gotta remember the name of it, Bash on Ubuntu on Windows. Something like that. But basically they've built the entire Windows, or basically they've basically taken like Linux and like put it on top of Windows 10. So that has allowed like a lot more development stuff because you can run like full ELF binaries basically like inside of Windows through like a special type of like PowerShell that's running Bash. So yeah, it's very possible that would be true. But I think at that point you're basically installing just like the dev files for Ubuntu through Windows. But I don't know where support's on from that is like on Windows right now. But yeah, so there's definitely ways around it either way, but I haven't seen an official Crystal.exe compiler that runs on Windows. Okay, so next I'm going to kind of give you guys like some of the analogs between Ruby and Crystal. So you all know gems. In Crystal they're called shards. Super fun. The gem file is the shard.yml. So this is kind of cool because there's a lot more structure here. If you think about how many people here have ever like dabbled in Node.js? So the shard YML, even though it's YML and not JSON, is structured much more like a package.json. So it almost kind of treats your application like it's a shard itself, and then you declare like the dependencies underneath that. I'll show you an example of that in a little bit. You'll see what I'm saying. Bundler just uses the shards command, so you just shards and then bundle install, which is shards install, if you can think about that. So that'll just read your shard.yml and download all the dependencies from GitHub. Ruby gems is crystalshards.xyz. Crystalshards.com is taken. And then I don't know if anyone's ever heard of the Awesome Ruby list, but it's basically like this GitHub README kind of thing that people contribute to, and they list like all the really cool libraries. I always thought it was super useful to kind of call out that because it's kind of a curated list of some of the best shards for the Crystal language. So it's a good place to go look if you're looking like, what should I use in place of Rack, or what should I use in place of Rails? You know, it talks about like, here's some of the frameworks, here's like the background jobs. Like it kind of breaks it up into categories so you can find your own kind of analogs for the tools that you're using if you want to get into shard development. I mean, Crystal development. So setting up a shards project is very similar. Use shards init, and that'll basically create like a small directory structure in the shards YML file. It's blank. You can fill out your own details. Like I said, it's similar to the Node.js. It manages dependencies and the dependencies of dependencies. So in the case, it's much like the gems where it'll go satisfy all the dependencies of other things. So kind of keeps everything super lightweight. And it has Git-based repositories. So pretty much like unlike rubygems.org, which has like you ship your .gem file to them and they host it, everything just comes from GitHub because it's kind of compiled on the fly. So you go get the source, it puts it in a folder, and then when you go to compile, it pulls all that stuff in and compiles your app. Let's see. So one of the things that I was really interested in, and this is kind of the conclusion of this and why I got into the Crystal development, is the Ruby interop. So the best way, you can't obviously like write C bindings and do all that, but it's like a lot of boilerplate and it's hard. So the alternative to that I found was Sidekick. So the developer of Sidekick basically made sidekick.cr, which is a full implementation that's API compatible with Ruby. So if you have like big jobs that you want to start to try to write in Crystal, you can take those and basically ship them as a Sidekick server with your workers. Put like some of the heavier stuff in there that you want to offload onto the background and do faster, and then basically you just push it like it's a normal job to Sidekick, and your Crystal code will basically run the job, and it's fun and easy. So to kind of conclude this, I want to show what that looks like. Any questions while I set that up? Yeah, go ahead.
What are compile times like?
They're not bad. So to do the whole Sidekick server, it's like a few seconds. And then the other thing that it kind of has is, and that's in release mode. So like basically in debug mode with like less optimizations, it compiles a lot faster. So I'll show kind of what that looks like. And I can kind of show you guys kind of some demo code for what like a real world example looks like a little more. And I've also set up a GitHub repo, which I'll link on the meetup, with kind of all the code examples that I showed in the presentation as files that are right here. So basically I've created two projects, a Crystal project and a Ruby project. So if we dig into the Crystal folder, you can see, so this is what a shard.yml looks like. It's very simple, but basically it declares the name, the version of the project, and then any dependencies. So I basically just specified Sidekick as a dependency, put the GitHub username, path, and the branch I want to pull from. Go ahead.
Can you increase the size?
Oh yeah, sorry. I thought it was small on my screen too. Is that better? I'll make the text bigger. It's not better? Is that better?
Whoa.
I think that should be better. Is that better?
Yeah.
Okay, cool. Yeah, so name, version, dependencies, tree. So this is kind of what a basic server looks like. So this is basically just bootstrapping the Crystal server. So you're including the Sidekick CLI, you're requiring your worker, and then doing the configuration. And the configuration kind of just continues with the host name, DB, pool size, and then you basically just start the server. And then the job for that looks like this. It's a very basic job. But basically, if you can read Ruby, you can read this. That's one of the really nice things about the language. Declare your job class, you include the Sidekick worker, you set the Sidekick options, which say like, by default what queue should it run on, and whether or not it should retry the job. And then we just have a little perform action, which takes an options variable, which is a hash of a string to a string. So any kind of data you want to pass in, it should be pretty easy. and then it'll run this code, which basically just logs out whatever the options message key value is. And then on the Ruby side, we pretty much have a mirror of that with the Ruby job worker. So this is going to basically do the exact same thing, but in Ruby. So you can see like the APIs, the code, everything's very similar. And this is the server there. So again, like if you can write Ruby, I guarantee you can pick this up tomorrow and start playing around with Crystal. That's one of the best things about the language. And then we basically are just enqueuing a job. So this is gonna enqueue a job to the Crystal side, and then there's the same thing in Crystal. It's gonna do it to the other. So this basically sets up a Sidekick client and enqueues a job on the Crystal queue to the Crystal job worker with the argument of hello, this is coming from Ruby. And then on the Crystal side, we have same thing with the message hello, this is coming from Crystal. So this is where you can kind of see some of the compilation. So one of the things that might be different from running a Crystal example to a Ruby example, we can highlight here, which will be, so we have our enqueue CR file, or actually let's do the server. So you'll see here, and then let me just delete the server. So you basically just need to build that file, and then basically it can walk the requires tree to figure out what other things it needs to include, because this is all compiled. So since it's compiled, we have to have all the files that we're going to do get compiled into one binary. So the way that it does is it uses the require statements of all the files and just follows the entire tree, collects all those files, and then compiles them down to one binary. Let's see, so we'll do Crystal build server CR, so that's the file we're targeting. And then we don't have to include any of the other stuff because, like I said, it figures that all out. And then we give the release flag so it runs fast. And then you can kind of see what the time was. So that built the whole server about that quick, which is, I would say, about like an average. I mean, it's a basic server though. And we can run that. Oh. So basically, this is just saying run with a concurrency of 2 and watch the Crystal queue. So that's going to bring up, this is Sidekick running under Crystal. And then on the Ruby side, we can just be Sidekick. So this is basically going to, this is going to run Sidekick, targeting the .server.rb file that I showed you earlier with a concurrency of 11 for some reason, and it's going to watch the queue Ruby. How many people here know Sidekick? Maybe I should explain a little bit about what the queues are. So like queues are basically just a place for old messages and they're tagged. So we have one Redis server that has 2 queues. And one queue is Ruby and one queue is Crystal. So the Crystal server is only watching the Crystal queue, and the Ruby server is only watching the Ruby queue. So basically what we can do now, since we have those 2 things running, is on the Ruby code we can enqueue a message on the Crystal queue, and that'll actually make Crystal code execute from Ruby. So what we'll do is we'll say Ruby enqueueRB. All right, so this is the Crystal server that got the message from the Crystal queue that Ruby enqueued onto the Crystal queue that says, hello, this is coming from Ruby. So the way that code looks is this. So let me make it a little smaller. But basically what we've done is we've pushed to the Crystal queue the Crystal job worker with these arguments. So that kind of allows for that interop. So if you have a very intense thing that you need to crunch, and you think that it would be faster to do it in Crystal than it would be in Ruby, this is a really easy way to kind of offload that. And then these servers you could run 10 of these across 10 different servers for kind of that parallelism or distributed jobs or whatever, so that if you want to do a ton of number crunching on a huge data set, you can spread that across multiple servers by using this queuing system. And then you can basically write all your fun Rails interface, everything like that in Ruby, but do all the heavy lifting in Crystal very easily. Yeah, so that is about it. Any other questions?
So since Crystal is like a superset of like the Ruby
Sure.
syntax. Is there a way for you to tell the compiler to check just like valid Ruby syntax and not the extended Crystal syntax?
No, I don't think so. Like, they're not that close. I mean, they're like, I guess, like relatives, but like Crystal doesn't care a lot about Ruby, like in a sense. Like, it used it to kind of like build out its base syntax, but like in no way does it strive to be able to run Ruby code, let's say. You know what I mean? And neither vice versa. So it's kind of just a side effect that you can run a CR file in Ruby and vice versa. But like they've pretty much made pretty clear in their goals that like compatibility with Ruby is not like a feature or a goal. Yeah.
Since it's not an interpreter, does that mean there's no GIL?
Yeah, there's no GIL. So this is a bit advanced, but I can pull up kind of their website where they talk about this. But they use basically fibers for concurrency, and it's kind of hardcore. Let's see, Crystal. Let's try to get it. See if they have an example here. Yeah, but it's kind of something like this. So they have like the concept of channels. So you can basically spin up these different fibers that work like similar to threads, and they help manage kind of the threads so that you can basically have multiple threads that communicate with each other. But there's no GIL as far as I know.
Okay.
How easy is it to debug stuff in Crystal?
It's fairly straightforward. You'll actually do like a lot less debugging because of the type language. But yeah, if you can get it to crash, I think I haven't really like run into that a ton. But I would assume it's going to work pretty well with your typical like GDB and things like that to do like the hardcore debugging. Yeah.
You can actually use the whole host of like Apple debug tools, which is like really awesome because it links to the LLVM stuff.
Yeah. So you can use like GDB and all that type of stuff and LL.
You can also use like the Xcode profiler.
Yeah.
And, like, all that other those
So.
things are kind of fun.
Cool. Anything else? Any other questions? Anybody want to see any examples? Good. Yeah.
Have you done any low-level data manipulation?
What do you mean exactly?
Well, you said it was kind of in the Rust C level. Have you done anything?
Yeah, so I played around. I built a few
data packing and such.
What's that?
Like data packing and.
Oh no, I haven't
Okay.
really played with that at all. But you can definitely do that.
Okay.
Yeah, you're talking about kind of like doing like things where you're like packing to like binary or hex and things like that. Yeah, that stuff's like very useful. I think like especially like when you start getting into like the TCP and like, some of the lower level sites and things like that. Completely capable of it, but I haven't had a huge need for it yet.
Okay.
Yeah, and one of the other things that you can do that's like super fun is you can build like your own like library and then like import it from C. So you can basically like I was talking about this very briefly earlier, but you can like basically export like certain functions that you write in Crystal and then like call them from like C code and vice versa. So there's a few examples on the website that basically like call into like the SDL library to do certain things. Yeah.
You seen any like really different, really fun like Crystal libraries, like anything that's been like someone decided to build something totally different than like what's out there?
I'm trying to think.
Just something like super novel.
Not that I have like honestly like I do pretty boring work for the most part. So like but like 90% of my like research into Crystal so far is just finding analogs for things that I already use in Ruby. But they have like something called Kamal, which is like very similar to Rack, and like I said, like the guy from Sidekick ported his whole thing. So I thought it was super fun just to be able to call basically the Crystal stuff from Ruby and kind of get some of that internet op action. But yeah, sorry, I haven't seen anything too crazy with it yet. How about you?
It was like a really long time ago. Someone did like a kind of really funky VM that they implemented, like.
Oh yeah, like you're talking about like kind of how like Rust, like somebody like tried to build their own kernel in Rust or something like that.
Yeah, so I think it was like a university like project, and they built this VM that had something different about it that it was kind of fun like looking through it and seeing what
Okay.
they did. But like I haven't looked at it in a little while now, so I was just trying to think of like something that someone had done that was like in Rust someone built like a browser which is pretty cool or something like that.
Yeah, yeah. No, I haven't really seen anything like that, unfortunately. And the other thing to understand is like the language is pretty young, and it's not like really sponsored. You know what I mean? With like Rust, you know, they had like Mozilla behind them, and Go has Google. Crystal's unfortunately just kind of like a pretty purely open source kind of like movement going on right now. I think there's like one company, I forget the name of them, or kind of like the official like sponsors or company that like, has kind of like turned it out, but for the most part, it's very it's still kind of in a bit in its infancy. But I think it's very promising, you know, especially like with as many kind of Ruby people that are out there looking, you know, for something maybe a little more powerful for some things. Yeah.
Is any type of cross-compiling support?
Yeah. Yeah. So there's basically a flag, and this is actually how you build a C binding. Funny enough, but you can. Let's see here. Yeah, so you can cross-compile with the cross-compile flag, and then you just pass in the architecture, and then I'm sure you have to have like the proper like headers or whatever set up on your computer somewhere. Anything else? Cool. Well, is everyone super excited to go write some Crystal?
Yes.
Let's put Justin in the hand.